This is the last part of chapter 2, unit 2, lesson 2. This is quarters and dimes. So I have a Q and a D. And then I have 1, and I have 4 and 10, and I have 6 and 14. Okay, so working with this table, most students just thought about this in money. They said, what is 6 quarters worth? We even drew little pictures. 1, 2, 3, 4 quarters is $1. 1, 2 quarters is 50 cents. So I have $1.50. I know that there's 15 in $1.50. 14 quarters, same way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That gives me $3.50, which I know is 35. You can work a table any way, okay? So you don't have to always do proportions. If it's easier to think about it in money, which it was for most students today, that's how we figured this table out. Could you find the proportions? Yes. Could you multiply or add here? Yes. You can do this table any way you want. I just think that this is the easiest way since most people are very familiar with money. The last part that we have is 1 quarter. How many dimes is it equal? Okay, this would become our constant of proportionality. So I know that a quarter itself is 25 cents. And I know that a dime is only 10 cents. So if I had 10 and 10, that would give me 20. I would need another half of a dime, another 5, in order to get that 25. So I would need 2.5 dimes. Now it says in number 3, what value belongs there? We figured that was 2.5. What does it mean in this context? Where it's telling the students that it means that that's the constant of proportionality. That does not mean that if you take an actual dime and cut it in half, that it was going to be worth anything. Now most people argue, or most students would argue, oh, what about nickels? But that's not what the table says. It says quarters and dimes. So if you had 3 dimes and you had 2 whole ones and you cut the third one in half, now you just have 2 useless chunks of money. So in real life, you cannot have this value in the table because that doesn't work in real life. You can't have 1 quarter and an equal amount of dimes for the same amount of money. But for this problem, this is used as our constant of proportionality so that we can make an equation so that we could figure out any amount of quarters and any amount of dimes. That is the last part of the lesson. And now I'm going to talk about the raisins and peanut problem on the practice problem. So that says that there is one version of trail mix that has 3 cups. I'm going to write peanuts and raisins. One version of trail mix has 3 cups of peanuts and 2 cups of raisins. Okay, and another version has 3 cups of peanut, or I'm sorry, that was the first one. Don't mind my error there. It has 4.5 cups of peanuts and 3 cups of raisins. So I want to figure out if these two are equivalent ratios. The easiest way to figure that out is to go to the constant of proportionality. I can get the constant of proportionality on either side. It does not matter. Okay, so you could take the 2 to a 1, or you could take the 3 to a 1. It does not matter. Okay, I will show you both ways. So if you divide here by 3, you get to 1, which means if you take this divided by 3, you get to 2/3. Okay, now if I take this divided by 4.5, that gives me 1. If I take here, divided by 4.5, I would do that here. So I'm going to do it down here so I can write another table set up top. 3 divided by 4.5. The way you divide decimals is you just move the decimal over 1 and over 1. Okay, now we have how many times does 45 go into 30? It doesn't. So generally students will put like a tiny x and then a decimal, add a 0. How many times does 45 go into 300? That's going to be 6. Okay, 6 times 5 is 30. 6 times 4 is 24, 25, 26, 27. Now I have 30, and I'm going to drop down another 0. I can see here I had 300. I know I have 300 again. I'm going to get another 6, and it's going to keep happening forever and ever and ever. And that's why we put this repeating sign right here. I know from being a math teacher and learning that this is equivalent to 2/3. If you don't know that, you would have to take 2/3 and divide it out. 2 divided by 3. How many times does 2 go into 3? It does not. I have to add a decimal, 0. How many times does it go in now? Decimal up top, 6. 6 times 3 is 18. I minus the 18. I have a 2 down. I can see again that this will repeat and repeat and repeat forever. Okay? These are equivalent. So I can write 2/3 up there because it's a nicer way to write 6 repeating. Let's see. So I have when I get down to my units ratio or my constant of proportionality, for every 1 cup of peanuts in this recipe, I have 2/3 cups of raisins. And in this recipe, for every 1 cup of peanuts, I have 2/3 cups of raisins. Okay? So that means that since these numbers are the same, my ratios between the two are equal. The only difference is here I made, let's just say, 1 batch. And here, I made a batch and a half, okay? So if I were to do it the other way, okay, and get my constant of proportionality on the other side, I would have divided by 2, gets me 1. I would have divided by 2, gets me 3/2. Okay, then I would take this divided by 3, gets me 1, and this divided by 3, I'll do here. I have 1, that's 3. Put the decimal up top. Goes into, oops, sorry about that. Brought the 5 down too quick. Didn't do my subtraction first. So I'm bringing the 5 down here. 3 goes into 5.5. I know this is equivalent. If I can't see that, I can change this into a decimal. 3 divided by 2 goes in 1 time. Drop down the 0, goes in 1.5. Those two are equal. I will write 3/2 because it's friendly. So as I can see, it doesn't matter which side I would have gotten my constant of proportionality on, it would have been the same. So that means for every cup of raisins in this recipe, there is 1.5 cups of peanuts. Just like this recipe, every cup of raisins, I put 1.5 cups of peanuts. I hope that these videos have been a little helpful and insightful. Thanks.